Hello everyone. This video would focus on conic sections, specifically on parabola, and this is the first part. In this part, we are given an equation and we're supposed to determine the vertex, the focus, ends of the latus rectum, equation of the directrix, and the line of symmetry, and we're supposed to sketch the given graph of this given equation. Before we go over this first example right here, let's have a review on the basics of parabola. There are 4 cases of a parabola with vertex at 0, 0. And this is the first case right here. Before we go over the details of the first case, let's have the parts of a parabola. These are the parts of every parabola. The first one is the directrix, which is represented as a broken vertical line right here. And this is the vertex. Again, our vertex is at the point of origin 0, 0. This is the focus, and this is the line of symmetry. Please remember that the distance from the directrix to the vertex is represented as P. So I'm just going to go ahead and label that up here. So this is represented as letter P. Now the distance from the vertex to the focus is also represented as P. So this is another P right here. This tells us that for every point on the parabola, the distance from the directrix to the focus would always be the same. Meaning if we take this point right here, the distance from the directrix and the distance from the focus, these two will be the same. And that is true for all the points on the parabola. Now we also remember that if we draw a line perpendicular to the focus passing through the, or perpendicular to the line of symmetry passing through the focus, this is what we call as the latus rectum. So I'm just going to go ahead and label that up here. Now we remember that the distance from the one of the endpoints of the latus rectum to the focus is 2p. And the distance from, again, the other end of the latus rectum and the focus is, again, the distance is 2p. So pretty much the length of the latus rectum is 4p. Now we also remember that for every parabola, it will open towards where the focus is. So in this case right here, since our focus is on the positive x-axis, so the parabola will open on the right. Now, the formula that works for the first case is y squared equals 4px. So this is the formula for the first case. Now let's look at the second case. In the second case, the parts of the parabola would always be the same. We have the directrix, the vertex, the focus. This is the line of symmetry, and this is our parabola right here. If you notice, the parabola on the second case opens to the left since the focus is on the negative x-axis. Again, remember that the parabola opens to the side where the focus is. The formula that would work for the second case is y squared. It's pretty much the same thing as the first one. That's y squared equals 4px. So this is the formula that would work for the second case. Now let's move on to the third case. For the third case, the parabola opens upward since the focus is on the positive y-axis. We also have the directrix. Again, we have the vertex at the point of origin 0, 0, and we have here the axis of symmetry. Now, the formula that would work for the third case, again, whenever the parabola opens upward, is x squared equals 4p y. So this is the formula for the third case. Now let's move on to the fourth case. In case 4, our parabola already is facing downwards. It opens downward because the focus is on the negative y-axis. And we still have the same parts. We have the directrix, we have the vertex, and we have the focus, and the line of symmetry is the y. The formula for the fourth case is pretty much the same as the third case. That is x squared equals 4py. So this is the formula for the fourth case. So these are the 4 cases of the parabola with vertex at the point of origin, or 0, 0. Going back to this example right here, we are supposed to determine the coordinates of the vertex, focus, and ends of the latus rectum, equation of the directrix, and the line of symmetry of this equation, y squared equals 12x, and we're supposed to sketch the graph over here. So the first thing that we are going to do here is to determine the value of P. So then we go ahead and say that this type of equation that we have right here, which is y squared equals 12x, is actually an example of case number 1. So if we go back to the equation of case 1, we have y squared is equal to 4px. This tells us that this 12 that we have right here is actually the 4p. So you see the coefficient of the x here is actually 4p. So that we can go ahead and solve for p from here. So this means that we have 4p is equal to 12. Divide both sides by 4. So then we are left with p is equal to 3. So I'm just going to go ahead and write that down here. P is equal to 3. We remember that in this equation, our vertex is at 0, 0, or at the point of origin. So we can go ahead and have this as our vertex. And since our P is 3, that is 3 units to the right of the vertex, since that is positive, and this is case 1. So that would be 1, 2, 3. So we can go ahead and say that this is our focus. We can therefore say that the coordinate of the focus is 3, 0. So I label that with letter F right here. That's 3, 0. And our vertex, I label that this is V, and that is at 0, 0. Now we remember that the distance of the directrix is the same distance as that of the focus, but it's in opposite direction. So we can go ahead and say that our directrix is 3 units to the left of the vertex. So I'm just going to go ahead and draw the directrix up here. This tells us that the equation of the directrix is x equals -3. Now we're ready to sketch the graph of the parabola. Now we remember that there is a line that connects, or there's a line segment that connects from the focus to the vertex, and we call that point as the end of the latus rectum. And so we can therefore go ahead and say that since our focus is at 3, we need to figure out what is the value on the y, so that we can go ahead and use this original equation that we have right here, but this time around we will plug in 3 to the x, and so that we can solve for y. So this is how it's going to look like. So whatever the value of the p is, we plug this into the x, and we are supposed to solve for the y. So our equation would come out y squared equals 12 times 3. 12 times 3 is 36, so that's y squared is equal to 36. In order that we can solve for y, we are going to square root both sides. So then this gives us y is equal to plus minus 6. This tells us that if x, we plugged in the x right there, so if x is positive 3, then we will have one of these. We can pick any of these, so let's pick this positive first. So we can go ahead and say that from 3, our y value is 6. So we can go ahead and put that up here. And so we can also use the other value for y here, which is again our x is 3. We plug that in there. So 3 and the value of y is -6. So that would be on 3 and -6 down here. And this is what we call as the ends of the latus rectum. just gonna label that up here. So from here, we can sketch already the parabola. So this is the sketch of this equation, y squared is equal to 12x. And our line of symmetry is the x-axis. So I'm just going to go ahead and label that up here. So we already have solved the first problem. Now let's move on to the second example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, we're supposed to determine the vertex, the focus, the equation of the directrix, the line of symmetry from this equation right here, y squared equals negative 10x. Looking at this equation, this is an example of case number 2 since we have a negative right there. So I'm just going to go ahead and write it down here. Since this is case number 2, the general equation for case number 2 is y squared is equal to 4px. And again, we remember that the coefficient of the x here is equal to 4p. So I can go ahead and label that up here. So we have 4p is equal to negative 10. So I will show the work to solve for p. So our p value is negative 5/2. So that we go ahead and sketch the graph. We remember that given this equation right here, our vertex is at the point of origin at 0, 0. So I'm just going to go ahead and label that down here. That's the vertex. Our focus is negative 5/2p units from the vertex. So that's going to go to the left. So 5/2 is negative 2.5. So 1, 2, 2.5. So it's going to sit here. So this is our focus. And we remember that across on the other side from the focus with vertex in the middle is our directrix. So I will draw the directrix on this side right here. Okay, so we can go ahead and say that our focus here is located at negative 5/2, 0. And the equation for the directrix is x equals positive 5/2. Now, we are ready to sketch the graph of this equation that we have right here. Now, there is another way that we can graph without having to solve for y and without having to do all the math. We remember that the ends of the latus rectum is 2p from the focus. It's directly above the focus and directly down the focus. So that means if our p is negative 5/2 or 2.5, so we go up twice 2p, so twice of the p is 5. So I go all the way 5 up and 5 down. So I go label this, and this will be the ends of the latus rectum. So let's determine the coordinates for the ends of the latus rectum. That would be negative 5/2, 5 and negative 5/2, negative 5. So I will write the ends of the latus rectum right here. So that we can go ahead and sketch the graph since we already have the ends of the latus rectum. So I will sketch the graph up here. Okay, so the equation for this graph that we have here is y squared equals negative 10x. And our line of symmetry is the x-axis. Did you get the same answers as this? Good, perfect. Now let's move on to the third example. In this equation, we can tell that this is case 3 since the coefficient is positive. So I'm just going to go ahead and label that down here. And then from here, we can determine the vertex. We remember that if we're given this type of equation, our vertex will always be at the point of origin 0, 0. So then since this is case number 3, the general equation for case number 3 is x squared equals 4py. And we remember that this coefficient 8 represents our 4p. So that we can go ahead and solve for p from there. I'm just going to go ahead and show the work down here. Okay, so from here, we can tell again that our vertex is at 0, 0. and then we label this as our V, that's the vertex, and then our focus is 2 units up since this is positive and this is case 3, so it's going to be 2 units above the vertex, so that's 1 2, so this is where the focus is going to sit, and we can go ahead and say that our parabola opens upward. And then from here we can go ahead and sketch the directrix. It's going to be across on the other side, so I'm just going to go ahead and draw that down here. We can go ahead and say that our focus is located at 0 2, and the equation of the directrix is y equals -2. So our parabola is going to open upward. Again, there are 2 ways that we can determine the 2 points on the parabola, so we can draw it. We will take the first method right here. So what are we going to do is we will use the original equation up here, which is x squared is equal to 8y, and then we will substitute the 2 to the y and solve for x, so that we can go ahead and write that down here. Okay, so what we actually did is that since we have the focus and we are supposed to determine the ends of the latus rectum that is along this line right here, so that we can go ahead and say that our y value was already 2 up here, and so we need to determine what is that value of x where this would go with, so that we can create the parabola. And so we had to plug in this 2 to the y and we solve for x, and so we can go ahead and say that these are the 2 values of x's, so that we can write this in coordinate form. So if we get a positive 4 that goes with 2, and we also have a negative 4, because again that's the x was plus minus 4, so that's a negative 4, and this was the y that we plugged in, so that is also 2 right there, so that we can go ahead and plot this on this graph right here. Notice that these 2 are the ends of latus rectum, so we can go ahead and label that up here. And so we're now ready to sketch the graph. We can tell that the line of symmetry for this graph is the y-axis. I'm just going to go ahead and label that up here. And so this is the graph of this equation that we have up here, x squared is equal to 8y. Now let's move on to the 4th example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Looking at the equation right here, this is an example of a parabola with vertex at 0 0. So I'm just going to go ahead and write that up here. Now, since the sign before the coefficient here is negative, this tells us that this is case number 4 since we have an x squared. So I'm just going to go ahead and write that down here. Since we say that this is case number 4, so I wrote the general equation for case 4, x squared is equal to 4py. So we can tell that this coefficient negative 11 is actually equal to 4p, and so I can go ahead and solve for p from there. I will show the work down here. So the value of p that we have is negative 11.4. So let's plot the vertex here. So it goes at 0 0. So I label this as vertex. And then our focus is going down from the vertex since this is negative 11 over 4. Now we remember that 11 over 4 is actually equal to negative 2.75. So I will label that down here. So that's 1 2 3, so 2.75 should not get to 3, so I will label this as the focus. So that's letter F right there. And so we can go ahead and say that the directrix is above the vertex, so I will draw the directrix up here. Okay, so we can go ahead and say that our focus is actually located at 0, this point right here, 0 and negative 11 over 4. And then the equation for the directrix that we have here is y equals positive 11 over 4. Now let's determine the ends of the latus rectum. We can either use this equation right here and we plug in this p-value to the y, or the easiest way that we remember is that from the focus to the one end of the latus rectum is twice the p. So I can go ahead and write that up here. Since our p is 11 over 4, if we double 11 over 4, it will come out 11 over 2. So I'll show the work down here. So this tells us that from the focus, we go 11 over 2, or 5.5 units to the left and 5.5 units to the right. And so we go ahead and draw that points right here. So this is the first end of the latus rectum, and this is the other end of the latus rectum. Okay, we can go ahead and say that these 2 points are actually negative 11 over 2, and that is negative 11 over 4. And the other end is, that's the first end right here. And then the other end is positive 11 over 2 and negative 11 over 4. These are the ends of the latus rectum. So that we can go ahead and sketch the graph. We can tell that our line of symmetry is the y-axis. So I will go ahead and label that up here. So this is the graph of this equation that we have up here. Did you get the same answer as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya!